positive terminal. Diode has two terminals. This is negative terminal, it is positive terminal. When N side of diode is connected to the positive terminal of battery, then it is reverse biased. So marginal current flows through it or current does not flow through it. So then once current does not flow, to A1, that is ammeter reading, in A1 is 0. Now current only flows to the remaining part. So 10 and 2 ohms are in series. Effective resistance is 12 ohms. So current is 12 by 12. Their potential difference is 12 volts, 1 ampere. So reading in A2 is 1 ampere. Here, two plane mirrors are inclined at an angle theta. When a ray incident on the first mirror, it gets reflected. So this is first mirror. It gets reflected. And here is a normal to the first plane mirror. Incident angle is alpha. So it deviated like this. Always while taking angle, arrows must be away from the point. So rays traveling in this direction. Here angle of incidence is angle of reflection. It is 180 minus 12. So deviation. So that means light is supposed to travel in this direction. So here it gets reflected and it is traveling. It is deviated by this angle. This is with respect to first mirror. And this angle is alpha. This will be 90 minus alpha. Say this is x. X plus theta plus 90 minus alpha forms a triangle 90 plus alpha minus theta. So once it gets incident on the second mirror, again it gets reflected. So here for this plane mirror, normal is this. X is this part will be 90 minus 90 plus alpha minus theta, which is theta minus alpha. So now it is supposed to travel in this direction. It gets deviated by this is delta. So 180 minus. So this is theta minus alpha. It is also theta minus alpha. 2 times theta minus alpha. net deviation will be 180 minus 2 alpha plus 180 minus 2 theta plus 2 alpha, which is this. So third option. So it is observed that wavelength corresponding to maximum energy by Wien's law, lambda m into T, is constant. So lambda 1 to T2. From here, T1 by T2 is simply, that is 0.13 by, both are in micrometers, T1 by T2. So ratio of emissive power is sigma A. It's Boltzmann constant. It is emissivity, surface area, T power 4. Since it's a black body, emissivity is 1. It's sigma A T power 4. So it's a Stefan constant. So this is P will be proportional to A T power 4. Since it is a same body at different temperatures, surface area will be same. So P1 by P2 is T1 power 4 by, that is 2 power 4. So P1 by P2 will be 1 by 6. Here you have NAND gate behaves like here input signal AB. So this is an AND means AND plus NOT. So there are two input signals. So AND plus NOT, that is by De Morgan's law. So another NAND gate, A bar plus B bar is the input signal. So output signal will be A dot B. So De Morgan's law, A union B complement or A intersection B complement or A plus B complement, A complement plus changes to dot. So it is A dot B. Finally, it behaves like a AND gate. Beaker A is filled with brim with a liquid. And beaker B is filled with liquid. Both beakers are viewed from directly above. The ratio of apparent depth. So this is virginal depth, mu equal to real depth by apparent depth. So apparent depth is real depth when it is seen from rarer. So this is the formula. So the ratio of apparent depth related to beaker A, it is d1 by mu1, that is liquid. Mu1 here is 1.3. Since he told identical beakers, depth will be same. So d1 and d2 both are equal to, let us say, d. Again, apparent depth is d by mu2. That is, here mu in the sense mu1, here mu2 is 1.6. So when it is observed from here, so the ratio will be d by 1.3 by d by, so 1.6 by 1.3. Here, many of the students, sometimes they don't concentrate on vernier calipers. So before explaining solution to this problem, I'll just revise concept. Here, to measure diameter of a cylinder, that cylinder is kept between jaws. Here, vernier calipers contains main scale as well as vernier scale. Suppose here, this is main scale. Here, 1 centimeter is divided into 10 divisions. Right. Is 1 centimeter. Vernier scale, this is main scale. Vernier scale, suppose vernier 0 here. Here it's 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 divisions of main scale coincide with 10 divisions of vernier scale. That means vernier scale unit is smaller. Here these are 10 divisions of vernier scale coincides with 9 divisions of main scale. So the least count, once you can measure this distance, once you can measure this distance, difference can be measured. The difference is 1 vernier scale division minus 1 main scale division minus 1 vernier scale division, which is called least constant or vernier constant. So here one main scale division, one division of vernier scale is 9 by 10 of main scale division, which is 1 by 10 of main scale division. That means here, so one main scale division is 1 mm because it's in fact 1 centimeter divided into 10 parts. So that will be 1 by 10 centimeters means 1 mm. Least count will be 1 by 10 of 1 mm, that is uh, 0.1 mm. Or 0.01 centimeter. This is vernier constant. Now, to measure, so diameter of a cylinder that we put between two jaws. Suppose here, like this is a main scale. So somewhere here, let us say 1 centimeter, and then vernier scales here again units something like this, it will be there. Here vernier scale division, it may be one in between, it's not till here is 1 centimeter, this here is 1.1. So here some small distance is there that we are measuring in terms of vernier scale divisions. So how much is this means? Here vernier scale division may coincide with one of the vernier scale division coincide with main scale division. That means this part, the gap is equal to if it is fourth division coincides 4 into 0.01 centimeter, that is 0.04 centimeter. Suppose here it is 1, so length of this will be 1.04 centimeters. This is how we measure length. Now here there are two cases. One case is vernier 0 is left of main scale 0. Vernier 0 is right of main scale J. That is, suppose here it is vernier 0, main scale 0 is, so if sometimes the coincidence will be there, sometimes instrumental errors. Vernier 0 is right side of main, we say positive error. When here vernier 0 is left side of main scale 0, this is negative error. As usual, we take reading like this. In the beginning itself, when jaws are kept closed, if you observe there is a positive error, then you have to see which division, vernier division, is coinciding with main scale division. Suppose fifth division coincides, that means 0.01 centimeter error, 0.05 centimeter error will be there. Then total reading minus 0.05 you have to do it. In case here negative error is there, suppose seventh division is coinciding, right? So when jaws are kept closer, vernier is left side of main, seventh division is coinciding. So you don't take 0.01 into 7. Take it as 0.01 into 10 minus 7. That is 0.01 into 3. So here you subtracted for negative error, you have to add it. This is the procedure. Now let us discuss this. Here vernier lies left of 0 of main. That means here it is a negative error. Which division coinciding? Seventh division coinciding. So don't take 7 into 0.01, you take 10 minus 7 into point. That is, error is 0.03. That has to be added. So vernier constant means least count. So original main scale reading is 7.7 and vernier 8 divisions. Each division is 0.01. This is original length if vernier 0 coincide with main scale 0. That is 7. Because of negative error, so we have to add 0.03, that is 7.81 centimeters, which is 780 millimeters. Here, this point, let us take it as A, this point. So let us take this as C. Between A and C, there is one resistance. Here D, E, F. So between B, D, E, F, there is no resistance. No resistance. That means they are at common potential. So once they're at common potential, so you can add D and E, like between C and D or between C and B. So there is another resistance because D and E are at same potential, I can take another resistance, or between here E and F also at same potential, I will take F also, same thing, like this. Now this is B, F, D, all are same. These three R's connected in parallel, R effective will be 3 by R by 3, based on 1 by R equal to 1 by R plus 1 by R plus 1 by R, 3 by R. R will be R by 3. So now circuit, if you redraw it, it will be R by 3, it is R. So effective resistance between A and B is R plus R by 3. That R here is he given 3 ohms. So effective resistance is 4 ohms. Your diatomic ideal gas is heated at constant volume until the pressure is doubled. At constant volume, pressure is proportional to temperature. So pressure is doubled So T2 becomes 2T. It's nothing but isochoric process. And again heated at constant pressure until volume is constant pressure means. So V1 by V2 is T1 by T2. Or here it's already reached T2 temperature. I will take initial temperature as instead of this, I'll write V1 by V2, but initial temperature is T2. Now I will make it T3. So here it is until volume is doubled. From here T3 is 2. Say this is 1. Right. So for entire process, final temperature minus initial, T2 is 2T1, which is 4T1. So the time gap is 3T1. At constant volume, heat absorbed is NCV delta T is diatomic. Gamma is 1 plus 2 by F. For diatomic, degrees of freedom 5. CV is R by gamma minus 1. 7 by 5 minus 1, that is 5 by 2 R. Delta T for first process, T2 minus T1. 5 NR by 2, which is 5 NR by 2 into T1. So next at constant pressure, heat absorbed is NCP delta T. Cp here is Cv plus R, 7R by 2 for diatomic gas. Delta T will be, that is final is how much? 41 minus 2T. Actually, we have to write T3 minus T2. So the T3 is, so let me write one more step. 7 NR by 2, 4T1, right? T2 is 2T1. So 7 NR by 2. So for entire process, molar specific heat we don't know. It is, I will add heat absorbed in both cases. 2 into this is 19 NR by 2 T1. And delta T here is for entire process 3 T1, which is 19 N R T1 get cancelled, N get cancelled. So specific heat will be, which is he given it as KR by 6. So K here is 90. Here current of 3 amperes flowing in a primary coil is reduced to 0. So there is a change in current, there is a change in flux. Then secondary coil EMF once current flows through it, magnetic field lines will pass through it. If there is a change in current, there is a change in flux. So when change occurs in first coil, because of that, there is change in the magnetic flux in second coil, which is called mutual inductance. Here I current flows, then change in flux is proportional to the current which flows through it. That phi here is EMI. So once there is a change in flux, EMF is induced. So induced EMF is dt of MI. M di, I final I is this. Initial current is 3 amperes in an interval of time 0.01 seconds, that is 10 Q. So the EMF induced is how much? 15,000 volts. So here mutual inductance is 5 henries. Of radius, making 300 revolutions per minute. Once it is rotating about its own axis, so any part of the ring will be under the tension. So if you take a wire, stretch from both ends, the tension will be developed in the string. Here also, so there will be a tension. Let us consider a small part of length dl whose mass is dm. So that is under stress. The tension will be developed here. Let us take horizontal component. So these two horizontal components are opposite to each other, they get cancelled out. Here it is 90 minus theta. Here also t sine theta. So 2t sine theta is balanced by centrifugal force, that is mr omega square. In fact, you take small angle d theta. Here it is 2t sine d theta is dm or omega square. For small angles, d theta, for small angle d theta, sine d theta is d theta. So 2t d theta is dmr over the cell. So here it is. If you draw a line, this is 90 minus d theta. It will be d theta. It is d theta. It is also d theta. So for 2 pi length, 2 pi angular measure means for complete circle, mass is this. For 1 unit angle, for 2 d theta, this will be the mass, that is, which is dm Farads. 2t d theta is, in place of dm, 2 pi r omega square. 2 get cancelled, d theta get cancelled. T here is mass, it is 2 pi, radius 0.25, 300 revolution per minute. One revolution is complete rotation, 2 pi radians, that is 10 pi radians per second. Omega square is 100 pi square. So 0.25 into 100, 25. Pi square roughly 10, which is 250 newtons. So internal energy of gas molecule for 1 degree of freedom is half kT. K here is Boltzmann constant. Here oxygen is diatomic. So 3 translational, 2 vibrational, 5 degrees of freedom. So internal energy for 5 degrees of freedom is 5 by 2 kT. Here he given mole. So 1 mole, Avogadro number of molecules. So for this, energy associated is all of you know that K into Avogadro number is universal gas constant. This is for 1 mole. So here how many moles? 2 moles of oxygen. Energy associated is 5. Argon is monoatomic, 3 degrees of freedom. For 1 mole, it is 3 by 2 RT. So for 4 moles, energy associated is 6 RT. So total internal energy is 11 RT. Here, this is standard problem. Recently, in many papers, this type of questions they are giving. So work done is equal to integral PD. Why I am using integration? Volume changes. If it is constant with respect to temperature, then we write PV. Here it is P. PV here is nRT For 1 mole, it is RT. In place of P, I will write RT by so V is this, dV will be, that is 2K by 3 T power minus 1 by 3 dt. So R volume is Kt power 2 by 3 T into T power minus 1 by 3 dt. So R I took T by V 2K by 3 dt. This T into T power minus 1 by 3 T power 2 by 3 key get cancelled out. 2R by 3 integral T1 to Tt. Is 2R by 3 T2 minus T1. That is nothing but 20R. So K value is 20. A parallel beam of uniform monochromatic light of wavelength has intensity. First, intensity definition. Energy incident per unit area per unit time. So for 1 photon, energy is this. For n photons incident energy, area, time is. So if your number of photons in 1 mm cube, if you take length as 1 mm, since light is traveling at its velocity, so T will be L by C. Hc is 1240 electron, 1240 roughly electron volts nanometer, 1.6 into 10 power minus 19, C 3 into 10 power 8, and area is 1 meter square. 10 power 1 mm is 1 by 10 cube mm meters. So 10 power minus 3 whole square. Again, length is 10 power minus 3. So it's nanometers. I'll write 10 power minus 9 meters. And lambda he given 2640. 1 angstrom is 10 power minus 10 meters. So let us take first 1240, 1.6 into 3 numericals, 2640, 10 power minus 28, 10 power minus 20, 10 power minus 13, 10 power minus 6, 10 power minus. Ten power minus 6, 10 power minus 9, 10 power minus 19, that get cancelled, 10 power minus. So N here is intensity is 200. This is 1 by 10, 10 by 2640 by 1246 into 1. It's roughly, if you multiply with 2480, but it is little more than 2. There 4.8. It is, I think, 1. It is also slightly more than 2. Coming around nearer to 800, which is 100x. Roughly 8. No, next one here. Ratio of concentration of electrons to that of holes. Concentration of electrons to that of holes in semiconductor. Ratio of currents is 7/4. We know that drift current is, remember it as V naught. So here it is IE by IH. So related to electron current, related to hole current, this get cancelled out. What he is asking, drift velocities of electron, drift velocities of hole. Ne by NH 7/5, which is, so that is in the ratio which he given it as K/4. So error in measurement of diameter of sphere, it is KR cube. Log V is equal to K, log K plus 3 log R, 3 times delta V by V into percentage error. This is percentage error in volume. he given percentage error in measuring diameter or radius. So this is what the answer.